Hi, good morning students and parents. My name is Mr. Young and today we're going to do a short lesson on 1.1 powers and exponents. So our standard is going to be 6th grade evaluating expressions A1, which is basically writing and evaluating numbers with whole number exponents. And here we have our vocabulary words: base number, exponent, power, and perfect squares. And we'll go over that as we go forward with this lesson. All right, so let's go ahead and begin with some basic understandings about what exponents and powers are. So to begin with, you need to understand that the bigger number is going to be called your base value. The smaller number up top is going to be your exponent, or also known as a power. So basically it's the same thing. You're talking about the same thing, okay? All right, so you could say this in one or two ways. You can say 7 to the power of 2, or you could say 7 squared. All right, and how you solve this is basically you write 7 that many times. So we're going to write 7 2 times. Now, as you see there, we have 2 7s. Now, anytime you're working with exponents or powers, you have to multiply. It doesn't change. You don't add, subtract, or divide, but you multiply. Now, the multiplication symbols, a lot of people use the symbol like that, like an X, or you could even have like somewhat of a like circle or in between them, okay? But as we go further, we'll talk more about multiplication symbols. Now, all you do from here is now you multiply. 7 multiplied by 7 is going to be 49. So that being said, 7 squared equals 49. And just be careful, please do not multiply 7 times 2. It does not equal 14. Always again, remember that you multiply the base number to itself that many times. So again, you see the base number 7. There's 7 to the second power here. And all you do is write 7 that many times. So because there's a 2 as the exponent, I'm going to write 7 twice and multiply 7 to itself, and I get 49. All right, ladies and gents, what we're going to do next is take our repeated factors and make them into exponents, and then finding our value. Now, anytime we say find a solution, find a value, we want to know what the answer is, okay? So anytime we see value, what is the answer? That's what we're asking about. All right, so our repeated factors, anytime we multiply, we work with factors. So 10 times 10, all right? So in your head, you know that 10 times 10 equals the value 100. But how do we write that as an exponent? Well, you see your base number is 10. How many times it would write 10? 1, 2. So we have 2 factors, and our base number is 10. So that's going to be 10 squared, or 10 to the power of 2. On the bottom, you see 1, 2, 3, 4, 5, 6 2's. That means our base number is 2, but there's 6 of them, okay? Now we got to find out what our value is. You could do this in your head. 2 times 2 is 4. 4 times 2 is 8. If you double that again, 8 times 2 is 16. 16 times 2 is 32. And 32 times 2 is going to be 64. So the value is 64. Again, you know that 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 32 times 2 is 64. All right? And what you guys are going to do is you're going to continue that with exploration 1 and finish out that, I guess, that chart. Okay, so with exploration 2, yes, you can use a calculator for this one. And what we want to do is have you guys look for patterns. So if you look behind me, you have your base numbers and your exponents, or your powers. So you have 11 to the first power, 11 to the second power, 11 to the third power, and 11 to the fourth power. So all you do is plug it in your calculator. Remember, you're multiplying the base number to itself that many times. So in this case, if I have 11 to the first power, that would be like 11 to the first power would just be 11 times really nothing, because you just write 11 one time, and that's just going to be the value 11. So I have 11 here. Now what I want you to do is continue to rest. So 11 squared, 11 to the second power, you multiply the base number to itself that many times. So you're going to have 11, write 11 twice, and you multiply that to itself, and then you find the value for that. Same thing for 11 to the third power. Multiply 11, write 11 three times. 11, 11, 11, 1, 2, 3. Don't forget to plug in your multiplication symbols. And 11 times 11 times 11. What is the value? You figure it out here. And so on and so forth, okay? Now what I've noticed in the book, and it doesn't have this, is that top box. Just so you know, that would be like, if this is 11 to the first power, that would be 11 to the 0th power. And anytime you have a base number to the 0th power, just know that no matter what the base number is, it's always going to be 1. Anything with an exponent 0 is always going to be 1. You could have literally 1,000,000 to the 0th power. That's still going to be 1. Okay, so just a quick reference. Again, if you have any questions, concerns, need clarification, students and parents, you do know my phone number, and you guys can reach out to me. All right. Okay, so the last thing I want to talk to you guys about is perfect squares. So behind me on the whiteboard is a pattern of dots. So what I want us to do is look at what perfect squares are, just to have you guys have a really good understanding. Okay, so on the first set, we have 1, 2, 3, 4 dots. The second set, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Third set, you have 4 columns, 1, 2, 3, 4, and 4 rows. So there's going to be 4, 8, 12, 16. So this would be 16. 5 times 5 is going to be 25. Okay. Now, in other words, we're kind of like thinking of a perfect square, and for me, that automatically says square root. So what is the square root of 4? What is the square root of 9? What is the square root of 16? And what is the square root of 29? Or 25, I'm sorry. If we look at the first one, technically the geometrical shape is a square. The second set is a square. Third set is another square. And the fourth set is another square. Now, just like a tree, you look at a tree, what is holding the tree down? What is giving it its life supply? The roots. So the roots are located at the bottom of the tree trunk underneath the ground. So this would be the roots, the bottom row. So in other words, if you really think about it, the square root of 4 is going to be 2. The square root of 9 is going to be 1, 2, 3. 3. The square root of 16 is going to be 4. The square root of 25, 1, 2, 3, 4, 5, is 5. In other words, it tells us that 4 is a perfect square, 9 is a perfect square, 16 is a perfect square, and 25 is a perfect square. Okay, so let's continue this a bit further. So these are perfect squares. So we can say that if we multiply 2 times 2, the base number would be 2, and the exponent is to the second power. Okay. For 9, it's going to be 3 times 3, and that's going to be 3 to the second power, because you have 1, 2, 3 columns and 1, 2, 3 rows. Okay, so that does equal 9, but that's equivalent to 3 to the second power. Okay, then you have 4 times 4, that's 4 to the second power, and 5 times 5, that equals 5 to the second power. In other words, ladies and gents, you're all problem solvers, and that's what we want to do, is to teach you guys these beneficial skills, to go out in the world, and any problem that life gives you, you're there to figure it out and solve it. All right, I know it seems like a lot, but it's really not a lot. I'll have the assignment posted with all the problems. So I want you guys to do 1 through 47. And this is going to be due Friday, October 16th at 11:59 p.m. Prime Meridian. Okay. And other than that, you know my number, you know my email. You guys can message me on Schoology. And if you guys have any questions, please let me know. You guys have a good day. All right, talk to you later.